Hello everyone. You understood the difference between deterministic and non-deterministic finite automata. So in previous video, I clearly explained the difference between NDFA and DFA. So every DFA is nothing but NDFA. So DFA is present inside the NDFA circle. Okay, if you assume that this is the NDFA portion, then DFA portion will be present inside the NDFA. Okay, now for more understanding, let's take some examples of NDFA. So all these examples I have already covered in DFA section also. Let's take a language L1 which starts with A. Assume that our input alphabet sigma is small a and small b. Okay. So if a language starts with A, then the NDFA transition diagram will look like this. First of all, there is an initial state, capital A, and if you see a symbol small a, you will go to the state capital B, which is final state. Okay, and then you can accept any number of A's or any number of B's. That's all it. So in DFA, we take care about all the input alphabet on each state, but in NDFA, we doesn't take care about. The main concern here is how to get the desired language. That means here the main concern is the language should always start with A. If I start with A, I need not care about the symbol B on state A. Okay, let's take second example. Let's say language L2 contain A. So all these examples I have already covered in DFA also. So you can compare this transition diagram of NDFA with DFA. So contain A means initial state, it will take any number of A or B. After saying A, it will go to the final state capital B, and it will take any number of A's or B on final state. So this is the transition diagram for a language which contains A. So here you can easily see that a small a symbol have two different moves. One move is from A to A itself, and the other move is from A to B state. Similarly, let's say language L3 which ends with A. Okay, so in ends with A, capital A is the initial state. If you see A, then you will go to the next state, which is final state. Okay, and here on A you can accept any number of A or B. Okay, so this is the transition diagram for a language which ends with A. Okay, similarly I can draw for AB string also. Let's say a language L4 starts with AB. So you already draw the transition diagram of a language which starts with A. You can easily draw the language L4 which starts with AB. So from this observation you can find out that capital A is the initial state. Then I have take a transition on a small a and go to state capital B, then take another transition on a small b and go to a final state capital C. On capital C I will take any number of A's or B's, it doesn't matter. Okay, so this is the transition diagram for AB, starts with AB language. Now fifth language is, let's say, and contain AB. For contain AB, it is very much similar to the language L2, which contain A. So here in place of A, I will replace AB. So what I will do here is, I will take an initial state, and on small a, small b, I will take a transition on A itself. On small a, I will take transition on capital B. On small b, I will take transition on capital C. Capital C is the final state, and final state will accept any number of A's or any number of B's. Now the last, let's say F L6. L6 is ANDs with AB. ANDs with AB. So the transition diagram will look like this. Capital A, on a small a, go to capital B. On a small b, go to capital C. Capital C is the final state. Okay, and on initial state you can accept any number of A's or any number of B's. Okay, so this is the transition diagram for a language which ends with AB. If you compare this language and this language, you will find that both are similar. Here the difference is, I will take the language which ends with A. Here I will take the language which ends with AB, but the procedure is, and the diagram is very much similar. Okay, so similarly you can practice other examples also, which I have covered in DFA part. Now the next thing is, in the previous video I told you every DFA is NDFA, because the transition function of NDFA covers the transition function of DFA. Okay, what I mean to say, the transition function of DFA is Q cross sigma tends to Q, whereas transition function of NDFA is Q cross sigma to 2 raised to the power Q. Okay, so here I can say every DFA is, because it contains into this, every DFA is NDFA. Similarly, I can also prove that every NDFA is converted to DFA. How? By using various methods. The popular method is subset construction, which we will discuss shortly. So subset construction method tells us that every NDFA, non-deterministic finite automata machine, is converted to deterministic finite automata machine. That means every NDFA is also a DFA, and it is stated that DFA and NDFA are equivalent in power. So both the machines have equivalent power. Okay, so this is very important result. Many times gate questions are directly asked from this concept. So you remember that every DFA is equivalent to NDFA in power. Okay, so in the next video we will take subset construction method and try to prove that how NDFA can be converted into DFA machine.